I'm not trying to turn the camera on, but it's not working.
Okay. Well, if you could just try a couple of times while I'm talking. Hang on, we appear to have a YouTube video here.
Yeah,
Okay,
actually, I'm
thanks for
thinking to
coming
use
to
my
listening to my
pre-recorded video for my
presentation today.
presentation because
My,
I'm pretty sure that this presentation will finish within 15 minutes. So
Okay. Well,
yeah.
I think the conference organisers would probably prefer a live presentation, but I guess if you don't have a camera feed, I guess that's one reason perhaps to use the one where we can see you. So, Roberta, if you're around, is there a ruling on that, or should we just go ahead?
Well, of course, with PDF slides is more interactive, but if there are some problems, I mean, Shotaro, do what makes you feel more comfortable.
I think that's right. Okay, so if you would rather do the video, Shotaro, that's fine. All right, I'll just introduce you briefly and then we'll begin. Okay, so as I was just saying, Shotaro Naganuma, who is a lecturer at Kyushu University in Japan, and he's particularly interested, as you can see from the title of the talk, in young people's interest in doing science or lack thereof. So without further ado, then I guess if you want to begin the video, I don't think I need to time that because it is 15 minutes, as you say.
Yep. Okay, I will start my video.
okay, thanks for coming to listening to my presentation today. My name is Shotaro Naganuma from Kyushu University in Japan. I am a lecturer in this university. And my presentation title is Why Student Interest in Science Declined on focus group of Japanese undergraduate students. If you are interested in this topic, let's exchange our opinion and research findings together after my presentation. Let's start from introduction part. As you might know, student declining attitude towards school science in early adolescence has been a big issue in science education. In Japan, around 1990, this program has started to get public attention, and recent TIMSS 2019 study has revealed that this trend is continuing. In TIMSS 2019 study, the percentage of Japanese students who do not like learning science is 9% among fourth graders, while 35% among eighth graders. Results for other developed countries such as the United States, England, and Australia were similar, as this table shows here. Under these situations, previous studies have shown that factors such as gender, early experiences, parents, and teaching quality affect student attitude towards school science. Many interventions such as project-based science curriculum, hands-on activities, and summer programs have been implemented, and many of them have shown positive effects on student attitude towards school science. Nevertheless, we are still facing a student declining attitude towards science program. One of the possible reasons is that there is a shortage of studies that have examined detailed process of swinging away from science. If we can obtain some insight in the process, it would be beneficial to tackle this problem. Therefore, this study examined how undergraduate students came to dislike science in their life using a qualitative research method. This is about method. We collected data in July 2020 via online environment, so Zoom. 22 undergraduate students in a public university who experienced disliking of science participated in this study, and half of them were female students. Their majors were diverse, like this. In data collection stage, as a pre-assignment, I distributed worksheet which I will introduce in the next slide. Participants drew their attitudinal change in their life along with for schooling time before university and wrote down any events to explain their attitudinal change. Then, each participant joined in a focus group interviews. comprising 3 to 4 students to supplement others' ambiguous memory and stimulate their own memory. This is a pre-assignment worksheet. Here is a full schooling time: lower elementary school, upper elementary school, junior high school, and high school. I asked participants to plot their attitude at each stage from these 5 lines, like this. For example, this participant was moderately interested in school science in both lower elementary school and upper elementary school. In junior high school, he had more interest, but his interest dramatically declined after this period in high school. He wrote that during this chapter down, he could not understand math, and then he could not follow science classes. All participants filled out this worksheet before their focus group day. In a focus group, each participant explained and supplemented this worksheet in their own words. After data collection, I coded those data qualitatively. I followed the constructivist grounded theory approach proposed by Kathy Chalmers. This approach contains 2 coding steps: initial coding and focused coding. MaxQD software was used for the coding. Here is a snapshot for MaxQD coding. As a coding rule, when more than 2 participants mention the same event, I use them for our subcategory. But if only 1 participant mentioned an event, we treated it as an exception. Let's move on to the results section. We discovered 14 subcategories and 6 categories. They are the 6 categories: comprehension, hands-on activity, teacher and teaching, autonomy of learning, perceived relevance of science, and engagement. I will explain them one by one from the next slide. The first category is comprehension. Many participants stated that their poor comprehension led to a negative attitude toward school science. This category is consisted of these 5 subcategories. These ones and these ones. In upper grade or upper educational institutions, science classes tend to have more contents to memorize, more invisible or abstract concepts, and more mathematical operations. These factors led to poor understanding of content and poor test scores and grades. Here is a quote for this subcategory. There was so much to memorize in inorganic chemistry that I gave up trying to remember it, and because chemistry is a subject where everything is connected, my understanding of the theory part went down, and I didn't even know where to restart. I called this quote as increased memorization. Here is another quote, which I called it as poor understanding. At first, I could not understand the equation ma=f in physics at all. I got stuck there. I couldn't visualize it at all. Even if I drew it in a diagram, I couldn't understand it. The second category is hands-on activity. If there were a few chances of observation or experiments, student science interest declined. Also, huge chances of observations or experiments deprive learners of opportunities to understand abstract science concepts such as electricity or energy. 9 participants mentioned this factor. Here is a quote for this subcategory. The number of experiments was reduced, and it became more difficult to understand the concept and the contents, even though high school students were doing things that were more invisible and difficult to imagine. On the other hand, 2 participants mentioned that one of the reasons why they disliked school science was the requirement of conducting independent research. Elementary school students are commonly assigned homework during the summer vacation in Japan. They need to set a question to be inquired by themselves and investigate it. This is a very demanding task, so the 2 students hated this activity. Here is a quote, which I will skip now. The third category is teacher and teaching. The first subcategory is poor teaching quality. Poor teaching quality led to poor understanding, which in turn led to a negative attitude toward school science. Also, poor teaching quality led to the formation of a negative attitude towards a teacher, which in turn led to a negative attitude towards school science. Here is a code for this subcategory, which I skip now. The second subcategory is teachers' unfavorable personalities. This discourages student active engagement in learning science, which constrains their understanding. Also, when students dislike science teachers' personalities, he or she disliked school science that they taught. Here is a quote. I asked a lot of questions, but I was rebuffed, so I had a negative feeling toward my teacher, and I didn't want to study anymore. The third subcategory is negative perceptions of a teacher. Student negative perceptions of teachers is brought about by poor teaching quality and teachers' negative personalities. In other words, students care both teacher teaching skills and personality. The fourth category is autonomy of learning. When participants felt their autonomy of learning was negatively affected, they lost their interest in science. There are two subcategories under this category. The first subcategory was strongly related to entrance exams. Before they recognized that science was a subject for entrance exam, they could enjoy science classes. However, after they recognized that science is a subject for entrance exams, their learning came to be forced beyond their own will of studying. Here is the quote quoted as studying for entrance exams. I felt as if science had become nothing more than a subject for passing entrance exams. The second subcategory comprises negative feelings about science induced by having to study for tests. This subcategory is similar to the first one, but this one focuses on general tests rather than entrance exams. The fifth category is perceived relevance. Four students mentioned that their negative attitude towards school science developed when they began to perceive school science as being irrelevant to their lives. Here is a quote. I chose a humanities course in my second year of my high school, so I had to study science for tests, even though I wouldn't be using it for exams at all. Then I came to hate science. Finally, engagement. Some students mentioned that a teacher's negative personality caused them to disengage. Here is a quote for this subcategory, which I skip now. Okay, let's summarize. This figure illustrates the relationships among the 6 categories and 14 subcategories. When at least one student mentioned the link between the 2 subcategories, we draw an arrow like this. The number in the bracket denotes the number of participants who mentioned each subcategory. In the macro view, it reveals that there were 5 categories except for engagement that directly influence the negative attitude towards school science. So this one, this one, this one, this one, and this one. However, in the micro view, we can find 3 interesting findings in this diagram. Firstly, several arrows indicating causal link is drawn toward poor understanding. So from this one, from this one, from this one, and from this one. In other words, understanding seems to be one of the important halves of the subcategories. Secondly, that the decrease in hands-on opportunities reduce understanding, leading to a negative attitude was a remarkable finding since such a role of hands-on activities has rarely got attention as far. Thirdly, this diagram also tells us the importance of teachers' personality since this subcategory has connection with other subcategories, so with this one and with this one. Okay, let's discuss our results. So findings of this study are consistent with self-determination theory because self-determination theory proposes 3 main intrinsic needs: autonomy, competence, and relatedness. In our results, autonomy of learning, comprehension, and teacher and teaching seems to correspond respectively. Secondly, the influence of hands-on activities appears to be unique to science education. However, the findings of the negative impact of independent research contrast with the findings of a previous study that open inquiry positively influences interest in science. In Japan, possibly we are introducing independent research too early for students. In practice, this study's findings emphasize the importance of hands-on activities for student understanding of abstract science concepts and of teachers' personalities in shaping student attitudes towards school science. Of course, this study has several limitations. The first one is about study sample. We use the data collected from public university students. Quantitative large-scale study is needed to generalize our findings in the future. The second one is about a retrospective method. A retrospective method is useful when we collect lifelong memory. We use the focus group to stimulate participants' memory from other student explanations. However, some of their memory would be missed. So we cannot say that we could completely exclude any biases in their memory. Future study should focus on the dynamics among factors to better understand complex attitudinal changes toward school science. Thank you very much for listening.
So thank you very much, Shotaro. Thank you for that talk, that recorded talk in this case. So that's excellent. So if anybody's got any questions, can you please put them in the chat? Okay. While I give people a chance to type any questions, I'll say I think that was very interesting. I think a lot of the points that you highlight there are ones that we will anecdotally recognise from similar cases around the world. So I think those are good insights. And a couple of people are typing now, so I'll be quiet and let those people put their questions.
Thank you.
Okay, so that's not a question.
Thank you
but,
very much for
yeah.
rebirth or libus. I don't know how to pronounce this, but thank you very much.
Yeah, I think it's probably reverse, but again, I don't know either. Yeah.
Reverse, okay. Thank you very much.
Okay. I think Geetika is also typing, so I'll give her an opportunity to put a question before we go on.
Thank you. I don't know why I cannot turn my camera on.
It might be a problem with your browser. I've had that issue myself on some other computers, so don't worry about it. It won't be your fault. Okay, Geetika's got a question. So she says, I completely agree with most of the points, but are the national curriculum in Japan accommodating these needs?
Accommodating these needs, yes. Actually, yes. The answer is yes, because in TIMSS and PISA study, it still shows this similar trend in Japan, and this phenomenon has been observed from 1990s in Japan. So now the government is recognizing that we need to involve the curriculum that focus more on science in our everyday life.
Yep. That's good, thank you. I think Geetika is just typing again. So again, I'll just give one moment. All right.
Can you highlight any
go on.
that they have made recently? Highlights. One main focus of the government is using the inquiry method in science classes, and another one is the connection between science and student real life. Am I answering to your question?
Yeah. Okay. Thank you very much, then, Shotaro. Sorry. So thank you for that talk. And then I believe our next speaker, as Geeta says, we are also using inquiry based in the UK.